Thank you. Anybody not get a syllabus? Pass that back. Okay, here's your syllabus. All standard details, including course content. Important dates for the class, test schedule, second page. I do give 4 tests in Organic 2. In Organic 1, we only had 3 tests. The final exam in Organic 2 is a comprehensive ACS exam, which covers both Organic 1 and Organic 2. Okay? 70 multiple choice questions covering both courses. There are national norms for that test. One thing I've started in the past couple of years is if you score 90 percentile or greater on that exam, which is a benchmark achievement, good score, 90 percentile on the ACS exam, I will award you with a certificate of achievement for doing that. And so hopefully that may be a goal of yours. I would like for you to all score 90 percentile and like to award you all a certificate of achievement. That is a nice accomplishment, something to work towards. Okay, tests here. Largely, this is what the course is about. It's a continuation of Organic 1. So you are expected to know Organic 1. That's pre-req. All right, we will be using Organic 1. We learned a lot of the foundation in Organic 1. All right. Organic 2, we put that to use. All right. Test 1, which we will begin today. Chemistry of alcohols, ethers, epoxides, which is a type of ether, and NMR. That's test 1. Okay? NMR, it will be covered by video only. All right? I have posted 3 videos already. There will be at least 4, maybe 5. All right? You covered IR in Organic 1, is that right? Mass spec. All right? UV Viz. NMR is much more involved. There's much more to it. It's not necessarily difficult. It's just a lot to it. But it's also very powerful. Okay, it gives you much more information than IR, et cetera, et cetera. Now, all of your spectroscopies sort of complement each other. You can't just forget any of them. But NMR is probably, to me and to most chemists, the most important analytical technique for organic chemistry. All right, a lot to it. Usually I have like about 4 at least lectures on NMR, 4 or 5 lectures. Then the test. All right. Well, at this point, we're going to do it by video, and you should start watching them now, not later. Since they're on video, you can watch them numerous times. You can pause. You can watch them on 2 times speed, and I can talk like this. Okay? If we only do it during lecture, you get 1 chime to look at lecture, and that's it. Hopefully you'll see the benefit. But you have to have some self-motivation. If you put it off and don't get into it, then you will be behind, and you will perform poorly on NMR. NMR will actually be on every test we have, all 4 tests. Okay? We will be doing comprehensive spec problems. I gave you one example in the pre-course worksheet, although that one did not include mass spec. I knew I forgot something. Yes. Okay. Syllabus. Great breakdown. Various comments. Okay. Further back is our daily outline. Today, here we are, right here, yeah? I'll also cover nomenclature by video only. I did this in Organic 1 for the first 2 tests. Okay, I plan to do that here. Basically, our class time is very valuable. All right? I want to get away from trying to rush through material so much and use class time a little bit more for some general discussion. A wee bit. There's still a lot of content. There's a lot of content in Organic 2. Nomenclature tends to be fairly straightforward. Okay? We can save 30, 45 minutes by doing that by video, and then asking questions in class and doing maybe a couple of examples. Again, you can watch the nomenclature video anytime you want in your pajamas, and you can watch it 10 times. Although I think 1 time or 2 times may be enough for nomenclature. Nomenclature is pretty consistent. Okay? But we will begin with alcohols and ethers. And there we go. And your lab, okay? What are we doing this week in lab? It's on the right. Either Thursday or Friday, depending on which day you come to lab. We will check in, and then we'll have lecture downstairs, okay? I considered doing a lab this week, but I decided not to. We'll do a little bit of use the time after check-in for miscellaneous things. Your first assignment is to read the syllabus and to then ask any questions. Okay? Either on Wednesday or during the lab lecture, I will ask you if you have questions about the syllabus. Now, as the syllabus discusses, it's good to write your questions down. Okay? So when your opportunity comes up, you don't, I forgot, what was I going to ask? Or, ooh, I didn't ask that. I meant to ask that and I didn't. Well, write your questions down. Hey, I have 2 questions right here. Okay, I don't have to think about it or forget to ask them. All right, I discussed this in the syllabus. Office hours requirements. All right. If you want me to help you, I need certain things from you. All right. If you don't give me those things, I'm not going to be able to help you. It's impossible to. My view. Okay, please read the syllabus. My background is in medicinal chemistry, drug design, organic chemistry, large number of compounds, the majority of them are small organic molecules. You know a number of these drugs, you've probably taken some of them. Advil, Aleve. Didn't we do a lab with naproxen sodium in Organic 1? Mm-hmm. Tylenol, Prozac, terbutaline used to control premature labor, I think, yeah. All these compounds have functional groups. Organic 2, we cover functional groups, alcohols, ethers. Test 2, aromatic compounds. Each one of these compounds contains a benzene ring. There's other types of aromatic compounds. Benzene is just the most common. Test 3, we get into carboxylic acid derivatives, such as carboxylic acids. And amide is an acid derivative. Test 4, we get into aldehydes and ketones. Here's a ketone, acid derivative. We'll see amines along the way. Just about every test will have some on amines. Ubiquitous. Okay. In addition to you being tested on your mastery of content knowledge, you will also be judged. Not necessarily graded, but you're always judged, everything you do around here. Okay? Whenever you go apply for a job, your reference will give an assessment of you. The reference is not going to say how well did you perform on test 3. The reference will discuss much more than that. Okay? Here's an example of something that I was asked to fill out about a student before. Okay? There are many examples of these. I added a couple other little entries here that you could be evaluated on. Some of you guys ultimately ask for letters of recommendation, and companies or schools ask us to fill these things out. Okay? Please think about that type of thing. Some of that stuff is mentioned in the syllabus, my expectations of you. Okay. For example, if you don't arrive at least 5 minutes before 8 o'clock, 7:55, I consider you kind of late. All right? We don't want to walk in at 8 o'clock and be able to be ready for the lecture. Okay? You don't have time to get in and kind of settle in and get comfortable and don't feel rushed. All right? That means leaving the house in plenty of time. If traffic is bad, that's okay. You've left early enough to compensate for that. All right? There's other things. All right? Please read. Please think about it. Okay. So, in a day or two, I'll see what type of questions you have about the syllabus. Any pressing questions at this point? Okay, again, NMR is by lecture only. You need to, I know a number of you, or some of you have already been watching the NMR videos and asking questions, even about the pre-course worksheet. I sent the answers out to that yesterday. But you can't look at the answers until you work the problems. I know some of you have been working problems, so I went ahead and sent that out. NMR basically didn't bring NMR tube, but the NMR is has to be done in the presence of a magnet. And we take the NMR tube, I showed the NMR tube on the videos, with the NMR tube in which your solution is, goes down into a magnet here, and that's where we do the procedure or experiment. Okay. The NMR phenomenon only occurs in the presence of a magnetic field. So you got to have a magnet. Okay. And then you can produce NMR spectra. This is NMR of a compound at the top, which I just made. I made that compound almost 20 years ago, but remaking that compound to be tested for tuberculosis by a collaborator in India who wants a large amount of that compound. And there's a proton NMR spectrum of the compound. Okay, baseline, right? What type of peaks occur about 7 to 8 ppm? Anybody? What type of hydrogens are those? Hydrogens that are attached to an aromatic ring. Yeah. Yeah. Okay. Peak position, etc. The textbook is Klein. It's paperback. Yeah. Anybody using a book other than Klein? Okay. It is okay to use another textbook. They're all about the same. I didn't bring my workbook. Somehow it got left off the card. I do produce a workbook that contains a lot of practice problems. It also contains the lab. Anybody have one of my workbooks? Either the current one or an older one? Can I demo this? Show this?
As long as you give it back.
You already what?
Just as long as you give it back when you're done.
Okay. All right, thank you. This is the one for 3412. Our course, it can be purchased only in the main chemistry and physics office upstairs. $15 cash only. No credit card capability upstairs. I produced this. $15 just covers the cost of the binding and the binding machine and paper cost, etc. Okay, there's a table of contents. You got to read the table of contents. You know what's in there. I had a student one time and near the end of the course said, I didn't know that was in there. And I'm like, I didn't know how you didn't know that was in there, because it's on the table of contents. Clearly you never read the table of contents and investigated what was in there. I didn't say all this, but that's what I was saying. Okay, you got to read the table of contents. The second half of this is the lab manual. I just call it the workbook / lab manual. But the workbook also contains the labs. It also contains, importantly, the guidelines. An overview of the Organic 2 lab. What's the difference in Organic 2? Well, we do more and more involved procedures, a little bit more sophisticated, and also allow you the opportunity to be more and more independent. Okay? More expectation that you're going to come ready to work. A little input from me. You know what you want to do. Lab safety guidelines, comments on notebooks, and pre-lab requirements, lab report requirements, checking into and out of lab, check-in instructions here. Okay. For me, I'm not going to tell you how to check in. All right, because the instructions are here. You come to the lab, I'll say, okay, guys, check in. And you check in. I don't need to tell you anything. Everything is written there. Okay? That's the way I am. I'd rather write it down, make it clear. You read it 100 times if you want. We don't have to waste time me telling you something. I don't read directions to you. I expect you to read the directions. If something's not clear in the directions, please ask. Routinely, I will update my directions because the student just didn't quite understand it. I'm like, okay, let me rewrite that. All right? A check-in sheet, which you'll submit when you check in this week. Lab safety, I need to sign that page. Some instructions about using IRs, melting point. You've done that before, rotary evaporator or rotovap, washing glassware, SciFinder database, which we will use more Organic 2. Then the labs. Most of these labs we will not be doing. This is my sort of collection of labs. The reason we're not doing most of them is because we are doing the multi-step synthesis of fluorine derivatives, which is an 8-week lab. So right there is 8 weeks. All right? It's an 8-week lab with a single report. All right? And it allows you some flexibility. You can check that out. We'll be doing that starting in about a month. Okay, there's a periodic table on the back. You need to get this as soon as possible because the directions for checking in, etc., are there. Thank you. And so you also want to be working problems. Now the workbook has a lot of problems for me. They're more like what you'll see on the test. All right? But they're intermediate or advanced level problems. All right? Your introductory problems are going to be in your textbook. All right? You must do introductory problems. You can't move on to intermediate or advanced level problems until you do intro problems, right? All right? The intro problems are going to be more in your textbook. Throughout the chapter, we learn how to do this, and then a couple of problems on how to do that. But most of the problems you'll see on the test are more sort of application or more involved, okay? Not just so elementary. You got to make use of your textbook. If you don't make use of your textbook, you're probably not going to do that well in the course. All right? I don't often refer much to the textbook. But everything I talk about is in there. Well, not everything. Mine doesn't have everything that we're going to talk about. But it will have 95% of the stuff we'll talk about. Right? And some other textbook will have that other 5%. I mean, textbooks vary about 5% of what they cover. Okay. We need to make some good progress today. Again, syllabus. Okay, the other two handouts. By the way, the NMR handout I sent you by email, and I asked that you print that on your own, or use it however, but sometimes you do a PDF and have a tablet or something. I've seen that. basically I'll tell you to print it on your own, but if you want to do something else, you need to have access to it sometimes even in class once we start looking at it. All right? But I'm not going to give you a handout of the NMR. That's that. The other white one today was our chemistry of alcohols and ethers. And then we had a green one. Okay, let's get into it. Alcohols and ethers. Okay. Wish you the best of luck. Hope you're here to work hard and learn something because it's going to be tremendously useful for you. This is a prereq to biochemistry. Who's taking biochemistry next? Okay? You're going to be expected to know things like shift bases and, chemistry of ME, carbonyl chemistry. All right? You want to be ready to go when you get to biochem. And in pharmacology or any other classes you want to take. And in lab, you want to continue to work on becoming more confident in your abilities to perform procedures and to get something accomplished in lab. All right? All right, this is your opportunity as well. In 5, 10, 20 years, you won't have the opportunity to go through a course and to be pushed to learn the material, et cetera, et cetera. In the end, you got to want to be here and you got to know why you're here. What do you want to accomplish this semester? Here's day one. Okay, guys, let's get going. Chemistry of alcohols. Now, once we get into this, a significant amount of this chemistry here will be a review from Organic 1 near the end with their substitution and elimination reactions. Okay? Again, Organic 1 is the prereq to this. We use a lot of that. Especially here at the beginning with this chemistry. All right, what can you do with alcohols? Also in Organic 2, we focus more on, instead of just the general type of reactions, we focus more on functional groups. So right here we're going to say, what can you do with an alcohol? What chemistry can an alcohol do? Well, an alcohol, you can do substitution, and you can replace the OH group with a nucleophile. Substitution. You can also do elimination. You can eliminate water. You can dehydrate an alcohol, and you can get an alkene, yeah? By like an E1 mechanism. You can alkylate the alcohol, put an alkyl group on the oxygen, another alkyl group, or R group, and the alcohol is now a what?
Ether.
It's now an ether. That chemistry we've looked at a lot in Organic 1. We're going to do it again, focusing on alcohols. What can you do with alcohols? New, okay? You can also oxidize alcohols, like to the aldehyde, and this can be further oxidized to the carboxylic acid, so we need to learn about oxidation of alcohols, which is very common to organic chemistry. And that's what we're going to be doing first. So this is sort of an outline of what we're fixing to do at the beginning. Then we'll move on to the chemistry of ethers and epoxides, okay? And for the first couple of lectures, this is what we're doing. This is actually an outline for all of test 1, okay? Right there. The only thing's not here, I think you add NMR to this, and that's test 1. Okay? By the way, I have moved up test 1 a couple of days from normal, since we're doing NMR by video. All right? Now, I wanted to do that because I don't want to be so rushed when we get to test 2, 3, and 4. All right? But again, I mean, the first test, I think, is on, January 30th. All right? All right. Which will include NMR. Okay, warm up. Many of my handouts will include some introductory questions. I call these sort of warm up pages. Dr. Hager taught me that term. He uses warm-ups a little bit differently, quite differently. Some of these questions may be sort of straightforward, but oftentimes they're a little bit sort of advanced, trying to get you thinking. This is what we're going to be, hopefully be able to do after we get through the material. Okay? Something to just get you thinking and challenge you at the beginning and see where we're heading. But you should continually strive to answer these types of questions. I also give you, try to give you application. What's organic chemistry useful for? Hopefully this will come through. I did this a good bit in Organic 1. Okay, some application to drugs, again. So, there's a couple of warm-ups. Next page, nomenclature of alcohols and ethers. Okay? Covered by video. All right? I created this video yesterday. About 30 or 45 minutes. All right? Very straightforward. Front and back that page. We will begin here, which is the same place here on the green sheet. We'll begin here, substitution reactions, and then we'll just work our way around, then we'll move on to elimination reactions, okay? That's where we're at. That's our overview. All right, substitution reactions of alcohols. Well, we know the OH group, the hydroxy or hydroxyl group, is a poor leaving group for rate determining steps. Okay, it's not going to leave in a rate determining step. That's what we learned in Organic 1. All right. How do you make OH a better leaving group? Most common is to protonate it with a strong acid. Okay? Must have H plus present to create better leaving group. Lg, that's me, it's my leaving group. Okay? And when you protonate the OH, you essentially, it's going to be not hydroxide leaving, but water leaving. Okay? All right, what type of reactions can we do? One of the most common reactions is to react an alcohol with HX, such as HCl, HBr. And this gives what? Alkyl halides. Okay, for those who are new to me, my handouts are strategically designed to give you important information and terminology. Okay? When you react an alcohol with HBr, what type of product do you get?
Alcohol.
An alkyl halide, specifically an alkyl bromide. Okay? Terminology is important. All right? But your headings give you that terminology. Don't just gloss over your headings and just not even look at them. All right? Read the heading. What is it trying to tell me? What's the terminology here? Because that's important. And it sets the stage for what are we going to do? How do we make alkyl halides? Okay, a couple of things first. First off, the X minus, okay, Br minus. Is that a strong or weak nucleophile? Now, I tried to give you some guides to judging that. Strong or weak? Why strong? Why strong? Because anion. And I told you, what are strong nucleophiles or bases? Anions? sp3 nitrogen? Okay. Yeah, according to that, you would call that strong. But it ain't that strong. Okay? So, think about it. In terms of base, if that's a strong base, it's going to react with this. Okay? Right? And it's going to form HBr. But guess what? That's a strong acid. And how does this usually exist? It exists like this. So if it exists like this, it's not going to act as a base and go back this way. So even though it's an anion, you kind of have to know it's not a strong base. It's the conjugate base of a strong acid. It's thus by definition a weak base. But it's also it's a moderate nucleophile. That can vary. In the end, the most important thing to know here is most anions can exist in the presence of H+. They're too strongly basic. But these can. By definition, they exist in the presence of H+. They exist ionized. So the good thing we have here is we can have our H+ to protonate our alcohol, but we can also have a good anion to act as a nucleophile. That's what HX provides us. Okay? Nucleophilic strength. Does this make sense? Isn't iodine the best nucleophile? Okay, it's larger. These guys are worse because they're better parents. They hold the electrons tighter. They're more electronegative. Fluorine is actually a very lousy nucleophile, at least in this class. Okay? In most applications, it is. All right? So remember your nucleophile strength. Mechanism, it can either be SN1 or SN2, depending on structural, okay? Depending on structure, you should have a good grasp of having to determine that. Okay, if you take this is a primary alcohol. That was discussed in the nomenclature video because the hydroxy group is bonded to a primary carbon. If you take this primary alcohol reacting with HBr, you can get the alkyl bromide. Okay? Now that right there is just a line reaction. Okay? I could give you this and say, okay, what's the product? And you should be able to show that. Because there's really no other chemistry that can take place here. There's really no other choice if you think about it. And a common reaction of alcohols is right here. And so we just have to kind of know that. There is a little bit of memorization in chemistry, okay? I will tell you you can't memorize. But you memorize sort of the entry level stuff. You memorize what you're doing, terminology. What you do not memorize is mechanism. We have to be able to work mechanism. The mechanisms are going to vary. We have to be able to think on our feet. SN1. This is a substitution. Everybody agree? Replacing the OH with the Br. Is it? You know two substitution mechanisms. Which one is this? It's SN2. Hopefully you know why. What's the first step? We can show this ionized. It's a strong acid. It exists ionized, especially in water. And so, or you can work covalently. First step is protonate alcohol. Okay? You got to know how to use mechanism arrows. You will be tested on your ability to show mechanism arrows. And this is going to give protonate the alcohol with a strong acid. By the way, this acid-base reaction we just did is not that favorable. If we actually draw something like this, it's actually more favorable to be that way. Okay? This is an equilibrium. And at equilibrium, we do not have much of this. All right? You can consider how to judge equilibrium. Okay? Think about that. Review that. That's okay. We can make at least one of these. From here, what's the next step? How do we get product? Nucleophile comes in and kicks off the leaving group. That gives that by what mechanism here? SN2. And what else did we create here in this reaction?
Water.
Water. We just synthesized water. Okay? Yes, it's an SN2 mechanism. It's a standard reaction of alcohols. You can make alkyl halides this way. How about the next reaction? Substitution, yeah? SN1 or SN2?
SN1.
Yeah, that's going to be SN1. Why SN1?
It's a tertiary.
The eventual leaving group is on a tertiary carbon. We never do SN2 on tertiary carbon. Now, as a tertiary, it's also benzylic. That's a benzene ring. It's going to be stabilized there. Okay, I reckon I'll do this again. Protonate here. Oh, we got a chiral carbon here with some stereochemistry. See, I would rather not take time to draw this. All right? Yes, it's a step, but I would probably rather just draw this protonated, because hopefully everybody can protonate an alcohol. All right? I did it in the first one. But if we have to protonate an alcohol 20 times, that's going to cost us 15 minutes throughout the test one time. And I can just hit. Now on the test, you need to show the step of protonation. All right? Protonate the alcohol, right? We get to this. Now what? We got Cl minus.
Leaving group leaves.
Cl minus would never attack here. We don't attack a tertiary. We don't do SN2 in a tertiary carbon. All right? But this can all I can do here is just ionize. All right? And importantly, and hopefully, you know how to use mechanism arrows. What does this arrow mean? WDAM. These electrons are breaking away from this carbon and moving on to the oxygen to become the second lone pair again. But the bond is now gone. This is going to lead to carbocation, right? Plus what?
Water.
Right. Instead of saying plus water, can I put minus water here? It lost water. Carbocation. What's the stereochemistry of the carbocation? Because this was either R or S.
Triple planar.
Not racemic. What is it? I can't hear, guys. Need to speak loud. I can't hear. Too many AC/DC concerts. Okay. Also, you want to make sure that your colleague back here in the corner can hear you. All right. Anybody again? Trigonal planar, which means in terms of stereochemistry. Right. This is tetrahedral. It's now sp2 trigonal planar. I'm not going to write that down because when you rewatch the video, you can catch it if you didn't catch it now or whatnot. Okay? I don't want to run out of ink here. Right? sp2 trigonal planar. Something that's planar has no front back. It's on the plane. There is no RS stereochemistry. It's not racemic. That implies you have both R and S. It's neither. We lose the stereochemistry. It's now planar. What's the next step?
Chlorine attacks the carbon.
This adds here. Okay? From here to there, that gives us our product, right? From here to there, what mechanism did we just do? It was a two-step mechanism.
SN1.
SN1. All right, leaving group leaves. All right, this would be your slow step, right? And then this would be a fast step. Remember reaction coordinate diagrams? All right. slow step of an SN1 is leaving group leaving. The nucleophile attacking is fast, relatively. So the nucleophile, for example, strength, doesn't matter. It doesn't matter how fast this is. This is what matters if you're looking at the rate. And of course, this overall mechanism included sort of an activation step. Protonating the alcohol was an activation, making the leaving group decent. Okay, what's this? The final product is now tetrahedral again, and thus chiral. What's the stereochemistry? Now we can say racemic, yes. And hopefully you know what racemic means. Why is it racemic?
Because in the pack step, when the plane attacks the
You attack the planar cation, okay? Here's your cation, it's planar. The chloride can attack from the front or the back. That will give you both enantiomers. Approximately 50-50. Now, we in Oriented 1, we probably always called it 50-50. You can actually sometimes get more like 55-45. It doesn't have to be exactly 50-50. That's basically because when the leaving group leaves, now this doesn't leave as an anion. The leaving group's at the top. When it leaves, it may not completely move away. If it's still hanging around the top, it's no longer bonded, but if it's still hanging around the top, it could block the top a little bit. Because it leaves, all right? But if it's still there, the chloride still has to sort of come in backside. You may see that in some textbooks or maybe in some question. Ultimately, usually though, we just call it sort of 50-50. And considering otherwise is more sort of an advanced look at what's going on. Okay, so there's a substitution by SN1. We're making alkyl halides by two different mechanisms. One below, you can supply your mechanism on your own, and we'll look at that next time. There's actually two down there below. So those are examples of converting alcohols to alkyl halides using what? HX. Okay? Where X typically meaning halogen, like HBr or HI. Now the HX can just be coming from HX, but it doesn't have to. What do you need for this reaction? You need H plus and you need X minus. Okay? They could come from just HX, or this could come from some acid, and this could come from like potassium bromide. Right? For example, like this. Or actually both of them. Okay? Because these are the two components you need. Leaving group better, here's your nucleophile if you want to make an alkyl halide. The Lucas test. The Lucas test is a test to tell you what type of alcohol do I have in here. Okay? What type of alcohol is in here? Primary, secondary, or tertiary? Lucas test can tell you that. You react your alcohol with HCl and zinc chloride. And you see how long it takes for a separate layer to form. Now, this test only works, I should write this here, only works with H2O soluble alcohols. And so you have one layer. It's mixed with the water. And then you add in this reagent, the Lucas reagent, and you see how long it takes to get two layers. The two layers comes from the alcohol being converted to the alkyl halide. This is shown on the next page. All right. Now, basically, we've already looked at HCl, yeah? Okay. Now, this reaction, this test is typically done at room temperature. And because most SN2 reactions are going to require a little bit of heat, this test usually operates by SN1. Okay? Did it say that on the previous slide? Okay. Lucas operates by SN1. Knowing that, which is going to react faster? Primary, secondary, or tertiary alcohol?
Tertiary.
Tertiary alcohol will react faster because basically this is going to protonate and ionize and form a carbocation fastest. Carbocation chemistry, SN1. And this will react with the reagent almost instantly. Secondary, a little bit slower, about 5 to 10 minutes. And your alkyl chloride is no longer soluble in water. Does that make sense? I told you these had to be soluble in water for the reaction to practically work. But when you convert it to this is no longer soluble because it no longer has hydrogen bonding capability. And most alkyl halides don't mix with water. And so as separate layer forms, you end up with 2 layers. The other layer forms instantly here, 5 or 10 minutes here. Primary, keep waiting. It ain't going to form a second layer because it ain't going to react. Because it ain't going to react by SN1. Now if you heated this up, it may react, but it's going to go SN2, and you wouldn't heat it because you do it at room temperature. So you do you mix everything together. Oh, I quickly got 2 layers. Well, it must have been a tertiary alcohol. Well, possibly a secondary if it's, but it's slower. This is the idea of the Lucas test to determine tertiary, secondary, primary. What's the zinc chloride for? Zinc chloride is a Lewis acid. When we protonate the alcohol, and I told you how that equilibrium is not good. Remember I told you that, pointed that out? The zinc chloride is sort of even a stronger acid. And if you show this, depends on if we show it just coordinated with 1 chlorine, that's a plus. And we can show it coordinating to the zinc. Okay. Sort of like coordinating to the proton. Okay. But you can coordinate to metal ions, just like you can to an H+. But your metal ions tend to be a little bit even more acidic than even H+, if you think about it. And they're Lewis acidic. It's the definition of a Lewis acid. We learned way back in Gen Chem. Lewis acid accepts an electron pair. Isn't that what the zinc is doing right here? We call it a Lewis acid instead of a proton acid. Okay. But it helps increase the acidity. And it helps. It's called the Lucas reagent. And actually our first lab, we will use the Lucas reagent. Yeah? Okay. That's the Lucas test. Again, primary, keep waiting. You ain't going to get 2 layers. Questions about today? Yes?
So in this, does the HCl not protonate?
Well, you can protonate with HCl, but the zinc chloride can also protonate, or zinconate it. Okay. A lot of times you use metal ions as Lewis acids to help increase the acidity. We'll have to dig deeper of how and why. A lot of transition metal ions will act like H+, zinc+, magnesium+. And these are called Lewis acids. just enhances the reaction. Okay, guys. Syllabus, yeah. Have a good day one.